Good morning, everybody. It's nice after a full day now to look at things, both science and the implementation of our work together. This is a session with a few of us, Khalil, Charif, and Johannes, and myself, and Antonio, and Beatrice, if I get it correctly. I got to learn. And then Roshan. So let's dive in. And if I ask you something, it's to remember two things, two words. That's really the main thrust of what we're doing here. The first one is trust. If nobody trusts our data, if nobody trusts our modeling, we're wasting our time. We're having fun, that's okay, but we're wasting our time. And that trust has to be pervasive. It has to go from the observations, the data and management practices, all the way through effective communication. And these are all linked. It's not that you can be in your own narrow area and really make significant progress. You have to work across the value chain, which I show here, starting from requirements all the way through the data processes and ultimately products and services. And that's what we want to keep in mind as we go. From a global perspective and a regional perspective, we also need to think about interoperability. Do you know what your colleagues are doing? Are they doing it the same way? Is the data interchangeable? Is the modeling comparable? Those are the things that we want to look at. And here, there's some thoughts about that I'd like to offer you. First of all, using consistent and recommended methods. This is important. I would love to see the methods linked. That is, if you have an EOV which uses multiple data sets, at least understand the linking between the measurements themselves and the EOV. We've had many challenges in terms of adaptation to local or regional infrastructure across Europe, even that's significant from Eastern Europe to Western Europe. When we work in Africa or South America, it's even more extreme because they don't have the people and the little physical infrastructure. There's always a discussion, I had that yesterday with Antonio and Beatrice, that unless we have a common vocabulary that we all understand, we're not really talking together. And so I add vocabularies, but it's also in data management and the universal metadata. And then finally, and with emphasis, a consistent approach to uncertainty calibration, basically data quality and understanding the limitations of it. And so from an interoperability viewpoint, think of it not just as working together, but that you have the infrastructure to support you in what you need. Okay, and with that introduction and just the two words I want you to remember, trust and interoperability, let's turn now to the discussions for today. And Khalil, do you want to come up? And
yeah.
One of the things that we're doing is trying to understand, working with Sabrina and the team, the areas where there are gaps in the EOVs and gaps in the methods. And, let me turn it to you.
Yeah, thank you, Jai. So, hello, everyone. So, I'm happy to be here. So, my name is Khalil Charif. So, just last February, I joined the OPSI for Clean IEEE with an amazing team. So, I come from a background robotic remote sensing to join the OPSI for Clean as a consultant to work in UAVs and methods. So, as I told you, I joined an amazing team, Jai, Rini, and Pauline, and other friends such as Belen. And the objective is to compile and analyze the maturity of UAVs and their best practices, maybe practices, not best practices, for their monitoring our ocean. So, in my work, on my research during these 1 month and 1 month and a half, 2 months. So we I created an Excel document which has like a 15 lines, 9 columns. The goal is to compile, to check how these variables are monitored and if the practices for these variables are to identify clearly like the ones that are adopted and well spread around the world, and to check their maturity. So the methodology basically is in this document is first I go through to identify if this variable is UEVs or ACVs or both. Then I give a description or like variables role on monitoring ocean and climate studies. Then I go to compile the key documents that identify these practices, the best practices for this variable, for each UEV variable, and check if they are available in OpenPS. Then I go to see if there are like the links provided for easy access, UI and UL. Then I try to check the maturity level using the 5-level scale. I think Jai will explain that very clearly in his presentation. And I move to compile all the specific practices for each UEV and the references, like within checking the maturity to see if these methodologies are well really adopted by the scientific community. So that's all for my recent 1 month and 2. Actually, there is no result till now, but Jai would like to talk more about that, and I wish to see you soon in a deeply presentation. So in 1 month or 2. Okay, thank you very much.
Thank you. I did want to acknowledge that Khalil is working with Belen and the OOPC, and what we are doing, and I should say Sabrina also, what we're doing is updating, or what she's doing is updating the EOVs to bring them up to the next generation. The BioEco has been doing that already. They have samples, and we're looking forward literally to the next month or few months. So keep looking at the EOVs, look at the new definitions, think about them, because they will impact what we're doing. Johannes.
Yeah, thank you. Yeah, thanks. So I would say a few words on uncertainties. It touches a bit on what was just said, and also it will be expanded, I have to already say, by Tanya this afternoon or later in the day. So uncertainties, why do we care about uncertainties? I'll put it like that. I like to emphasize it again and again and again. There is an uncertainty dimension, so to say, in EUVs. And uncertainty is key for using observational data. I guess we all agree on that. I will show you some examples. And what I show you here is kind of the Bible of ocean observing, which is a framework for ocean observing that came out of the Ocean Ops Conference in 2009. And inside of that document, there is a certain table that tells you something about the readiness level of the observing system. And the highest level ever for the requirement process is combined in what is called EOVs, this essential ocean variables. And these essential ocean variables have actually 2 characteristics. One is the sampling, and the other is quality specification. Quality specification, to argue that, you need to have uncertainties because you want to know how the quality is being, met by the observations that you are doing. Good. Then there is a certain issue, whatever, that there is a functional, so to say, complex or not relationship between a measurement, actually, and then a propagated uncertainty. And Tanya will, for example, say a few words on that. You can also write the EUV as a functional relationship between observations the relationship, and then some uncertainties that propagate. However, that's being done. I come to it. Because I come to it means we are, of course, not the first to do that. It has been already said on the first day from Sabrina that what we do is kind of using the system that's in place for weather, but now applying, so to say, the ocean to it. And what you see here in this unfortunately little text is actually what the WMO is expecting when you say uncertainty. When you want to report uncertainty in this WMO context, you have to, address a few requirements. They define actually what an uncertainty is, characterize the estimated range of observation error on the given variable within the 68% confidence interval. I mean, it's also what we do in science, but we have to make sure in this case that it really is like that. And yeah, providers of observation should interpret the rolling review of requirements uncertainty requirement as bias and random error combined in the root mean square sense. Okay, and that's kind of a thing. Then the term uncertainty is aligned to the international vocabulary of metrology. Not meteorology, but metrology. That are these guys that sit in a lab which is stable in temperature to 1 millionth of a degree, and then they do repeated measurements and they find out something, which unfortunately is not really in itself transferable to, say, a research ship that shakes around and there's temperature differences from 20 degrees. And so the base, so to say, is in this kind of guide here, which is called the GEOMAR. That's the guide to the expression of uncertainty in measurements. The challenge is to transfer this GAM thing into the real world. Okay, and then there's something on expected uncertainty as a quantity defined defining the interval about the result of the measurement that may be expected to encompass a large fraction of the distribution of values that could reasonably be attributed to the measurand at a typical 95% confidence interval. So what that says is exactly what I just said about this lab with a to a millionth constant temperature and the real world. Right? So it's really the expected uncertainty, not the uncertainty that is theoretically possible. So that's this GAM. If you look into it, it's shocking, I think. It really is a big guide and tells you a lot. The good thing is that there are certain people that already look into the GAM and try to transfer it into the real world. And this is just one example that I came about. It's estimating quality of indirect measurements of seawater sound velocity by CTD data. If you look into that document or that publication, it looks into what are the different types of errors that are associated with exactly this machinery here, using CTD data that has uncertainties, how to estimate the uncertainties, how do they propagate into the estimation of sound velocity, how good do I know sound velocity, blah, 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 all that stuff. And that is something that we need to have in order to address what the WMO wants for all our measurements, theoretically. Right? This is the level that they expect, and in fact, they have that level for the atmosphere. And because they have it for the atmosphere, we can either say, well, okay, we ignore it, and we just say, well, we do it in oceanography this way. Or we say, well, we take what they do in atmosphere and we try to implement it into the ocean. What then is important, if you have these kind of documents, then it needs to be, and it was said just now, it's just before, it needs to be part of the data. So it needs to be reported when I have this type of observations being fed into the system, that I say, well, it goes back to that document here. And ideally, it would be the document that's even referenced in WMO for the standard document to estimate the quality of measurements from the CPD. But this is actually then the link between data and the way you have estimate your uncertainty. So I think a very good example, and Tanya, I think, is also going into it, is sea surface temperature. Sea surface temperature is something that oceanographers measure, and sea surface temperature is something that's since decades in the WMO system because they are interested from the weather point of view in sea surface temperature. And so if you execute things across sea surface temperature, you are already in a world that's implemented, but you can see how they approached that world, how they approached the problem. What is shown here is the upper 10 meters of the ocean in different resolutions. And when we say essential ocean variable sea surface temperature, what it should demonstrate is that there are different measurements here that all are being used to estimate sea surface temperature. So from that, it's already evident that you have to very well describe what you mean when you say sea surface temperature, and also what uncertainties goes with it. That's very different if you use a skin temperature, foundation temperature, whatever, temperature 2 meters, temperature 10 meters. So again, the conversion from the measurement, which is all these little dots or all these stars, to the EUV sea surface temperature goes along with the methodology that needs to be, set. What methodology has been used, what uncertainties go with it. Last slide. So just to emphasize the dimension of uncertainty, again, sea surface temperature. This is now from this Oscar thing. And what you see is the EUV on the left, sea surface temperature, as I just said. And then the application area, also Sabrina was saying that yesterday, different application areas. And what is interesting, I think, what you should take home, so to say, is that depending on these different application areas, as said, sea surface temperature is important for weather as well. So there is forecast or nowcast, short-term, short-range forecasting, numerical weather prediction. There's aeronautical metrology, for example. They also need sea surface temperature. Of course, if you are longer predictions, seasonal predictions, you need also sea surface temperature. And what you can observe is depending on the application, there are different expected uncertainties. So what does that mean? If I'm now in a fishing vessel and I do temperature observations and I describe how these temperature observations have been done, and I come to the conclusion that my uncertainty is 1 Kelvin, which is not good for oceanography, but it's completely sufficient for our aeronautical metrology. If I have now, a high sophisticated temperature measurement, say that's with ship calibrated and so forth, and it comes to, let's say, hundreds of a Kelvin, right? Then voila, I can serve all these different application areas with this one measurement. With the fisheries vessel, I can do one, and with the other one, I can do all. So that's, that will, if we can make that clear, that my super well calibrated measurement can now serve 5 or 6 different application areas, that's a win. I have to show it somewhere, see what I can deliver with my observation to the system. Okay, and the rest, that's what I wanted to say about uncertainty and why it is so important to document it, how we do it, and how it reflects into the system.
Can I answer questions? Let's open the floor for questions. Go ahead.
So very What is the information about what you just said before, the different sea surface temperatures, skin, subskin,
This
or foundation in the table?
it's it's in, I think it's further to the right. No, it's not further to the right. It's in, if you click now on sea surface temperature here, but we could do that. You come in the Oscar. I can say in the Oscar. In the Oscar is further explanations on transfer of the temperature of different temperatures into that variable. So there are, in fact, if you go into the detail, there are applications or standards, procedures being described that are, say, the nominated or the official procedures to be applied in the system to transfer the one thing into another. So transfer the skin temperature into the sea surface temperature. And behind that, and I think that's also important to keep in mind, behind that are groups of experts, right? And for the temperature, for example, there's a GHRSST, the Global High Resolution Sea Surface Temperature Expert Group, and they actually discuss that. And if there is anything wrong, so to say, maybe there are people in the room that are part of the, of course, our friends from GEOMAR are in that expert team, and they discuss actually this kind of thing. And if there is, as we saw yesterday from Pia, if there are certain things that are not, that need improvement, that group is the group who will propagate it, so to say, into the system. They are the accepted experts, somewhere further to the right, are the accepted expert groups that care about this stuff.
Other questions?
Thanks a lot. So it's a very, very important topic, the uncertainties. And I'm just wondering, what could we do as a community in order to foster, or really, I would like to even use the word to ensure that the application of uncertainties will propagate into the application then into the products. Majority of the products doesn't provide any uncertainty maps. Reporting, and if it comes up to indicators, even WMO, there are some indicators which do not have any uncertainties. So how can we foster to bring this up really to this level where we need them to implement into these UV fields, also with an iMerge product, as we have seen for SST, that we have the uncertainties?
Yeah, that's a very, very good question, Karina. I really appreciate that question, because I think that very, very first thing that we should civilize is this, right? You see on and on and on this conference as well, on this meeting as well, they say EUV is equal to measurement. It's not equal to measurement. It is a functional relationship, however, with a measurement and an uncertainty. If we civilize the thinking that uncertainty is as important as a measurement, I think that's a base, right? If people cannot go through it just by delivering measurements, but only measurement and uncertainty. And therefore it's so important also to map not the measurements, but to map how is the actual state of the ocean in terms of measurement and uncertainty. Only this way we can, show we don't know actually what you were saying. I mean, we do not have statistics. It would be interesting to understand how many measurements have uncertainties.
Yeah. So it really comes down in part to making clear the methods to calculate the uncertainty and to make the assessment of it.
I think that should go hand in hand with it. Sure. Yeah, that's a reproducible term. Yeah.
Yeah, thank you, Johannes. It's a topic that is extremely important and interesting. We have examples now from the remote sensing SST community, mainly where they actually supply these uncertainties. They are on the boundary between meteorology and oceanography, if you will. Are there any good examples from oceanography where we actually supply? I mean, which program? I understand that not even the ARCO program. What about tsunami program? What about sea level programs? Do we have any good examples of where that actually works?
I think I'm not really sure, but I hope GoShip would be one of those, so high quality or known quality hydrographic data. Ocean sites, no, at least I know that we deliver uncertainties with our data. I mean, there are groups that do it, where it's normal to deliver an uncertainty with the data. And that's what I said. I mean, we have to do statistics. We have to see. We had that publication, for example, on a big experiment in the Western tropical Atlantic, where we did an exercise to allocate uncertainties to everything. Because, Tanya will say about it, there's this, say, primary uncertainty, I would call it, which is an uncertainty that comes out of a real application of a certain methodology to the data. And then there's a secondary uncertainty, which is really, estimating the uncertainty from the knowledge of uncertainty. So having 20,000 measurements without uncertainty, but 1,000 with uncertainty and with very good with no uncertainty. You can allocate, right? You can give every other measurement an uncertainty, which is large, but still, at least you know that's completely off. Right? And artificial intelligence will help here.
Last question.
If there's time, just a quick one on the GCOS ECV EOV requirements. There is a required measurement uncertainty for each EOV, one value. Here with I think that was the RRR, you have it broken down into application area. Do the two speak to each other? What's the link?
Well, I can only give you my personal opinion. That's not thought through. I think the way it's being presented is not thought through, because it is, as said, there's so many different ways in estimating uncertainty of a CTD profile. It was said it depends really on knowledge, on whatever, right? So you can theoretically in the ECD specification, you can say what to expect in terms of, but it's so no, I don't think they speak to each other.
So as someone that uses SST a lot, I've noticed that even if very often I do get the uncertainty in the data set, and XCDF comes with the field. In the end of the day, most of the time, my way of estimating uncertainty is to just look at two, three different products. So I just use, I don't. So my point is that even having that information, at the end, I don't use it, because sometimes for me it's enough to see that two different observations are so far apart that, yes, the uncertainty, that one becomes like less important for me than the fact that they are just different. Okay, so I'm saying this is important for certain people, it's crucial, I'm sure. But then for other application, I do climate variability, I look at linear example. Then for other application, for me, it's enough to get three products and see that the spread between observation is perhaps the same distance between observation and model.
Yeah, okay, that is simply, quick answer, that is simply because what you are referring to is not necessarily uncertain. What they are referring to is not necessarily uncertainty. What you do actually is what Tanya is doing, which is secondary quality control, right? You have some measurements and they're all different. You don't know what is really the real one. You want to at least harmonize them. Still, it could be a completely wrong value that you have in terms of accuracy. And that is, it has to do with socializing, right? With defining what is an uncertainty, and then having agreement among the community, and then the best practices also come into play, having agreement on how we do that, what we do, and then we will have at the end, and that is a KPI, at the end, you will have all these different street products the same, aligned, so to speak.
I think we need to move on, but this is the beginning of at least a 1 year and maybe 2 year discussion. Maybe we should have a workshop sometime among us because there's a lot of experience here in moving forward. I would encourage us also to think about when Johannes says point one can service everybody, but maybe point one isn't affordable for most people. So there's a lot of dynamics that has to go into what is the uncertainty that we really need for what applications. Okay, well, let's move on. I'd like to talk about now briefly best practices and standards. There's a number of people that said we have to move to standards, but I'm not sure everybody has worked with standards and what that means in terms of relation between best practices and standards. This is just a very short introduction of something I'd love to talk about sometime later also. As I mentioned yesterday, best practices evolve from individually developed methods. These are people in the field that are gaining experience and then sharing them. And the word best here is a very strange, I always like to put it in quotations because I've had people say you are a best practice repository. I don't know if mine's best, therefore I won't submit. And that scares me because we've got to get methods out and then let them mature to become best. And I'll talk about that later. Coming to standards, these are usually top-down. A standards organization, whether it's ISO or CEN in Europe or the IEEE, will organize working groups, teams, and they will go through and develop a standard and it will be adjudicated through the community. So that's more of a formal process, and I'll have a comparison in just a minute. But I want to emphasize with you that they're really standards and best practices, the same cats, maybe with different stripes. And so I think we need to think of them as a continuum and certainly will evolve best practices into standards, and standards will need best practices for their implementation. And so it's a tight-knit community. Okay, and just as a comment, we think of the word standards, but each of the organizations, whether it's ISO or IEEE, have different levels of standards. There's the standards, which is on the left here, and the word shall be there, which means you have to do it to be in using the standard. But they also have recommended practices. You should do this. And then finally, guides. Guides really are being used on how standards can work and how you implement them. And that is, you may do this. By the way, there are multiple courses of action you have to choose between. So when you say the word standard, think of this as a dynamic range of things from you must, such as interfaces for internet, to things you shall or should or perhaps even may do. The best practices is the same way, and I'll talk about this maturity matrix later, but we have good, better, and best. And in that same sense, the mature or sustainable at the right level 5 is equivalent to pretty close to a standard in the way it's formed. And let me give you a table on that. I'm not going to go through all of this, although I'd love to talk about it sometime. If I compare standards and quote unquote best practices, the creation process, and I look at number 2, line number 2, is done by a certified working group on standards, but it's done by expert panels and endorsement for best practices. So you're beginning to see the similarities. The big difference, and it's a big difference, is relating to access. Generally, standards you have to pay for. So they're behind what we call a paywall, whereas our practices are traditionally and will be, as long as we can do it, open access. And so we need to think about accessibility and other things when we relate standards and best practices. And finally, there was an interesting question of, are these standards, when they're applied, is the organization certified? Is the product certified? And in the standards world, there is certification as to whether you're implementing it right. ISO 9001, everybody has heard, as a certification of an organization. In the best practices, we really don't have that mechanism. Some do. GoShip is a wonderful example of continuing training and learning how to do things, but we don't have it, and it's something we should talk about. So I want to leave it there as a concept of what's a standard, what's the best practice. And let's now move to an agenda item. Antonio. Which is very, very interesting. We talked about the fact that not only should a EOV represent the what needs to be measured, but also how do you measure it? Because if you don't describe how to measure it, your measurements are going to be different. And we've been working with EMODNet, that is the Ocean Best Practice System, looking at the alignment of data and best practices, and actually in the metadata for the EMODNet, we are adding a capability to define the practice that was used in the measurement, and we're going to start working with the community to do that. And Antonio is going to talk about that work.
Thank you very much. As introduced by Jay, I mean, we started this exercise in order to see which is the level of this kind of information already attached to the data. So again, this is something that Jay already said, and I'm citing himself, because these are the basic conditions in order to be sure that we can really do and cover the full chain of the value of the data. So linked to what we were discussing yesterday, we were checking what is already available at the IMONET physics level. So you already know this. That, I mean, again, if you're looking at the data and you are a dummy user like Novellino is, usually who talks a lot, what he needs to do is to go to the portal, click on some things and see the data, as we already seen yesterday. But we know that in IMONET we are already collecting many data from different sources. So the level of, let's say, harmonization, it could be a bit fragmented, and we need to know about the best practice that has been applied to a given data in order to be sure that then when we do processing, we can group together this data. And it's not only about the, let's say, the data quality, because we have, for example, the in-situ tag that is already applying a harmonized way to ensure the data to apply quality check and quality flag. It's something that goes beyond this, because we really need to know if the procedure has been applied the same way. So if you need to go more deeper in the data, of course, you need to do something more than clicking on the portal, because you want to access to a given data package. This is the way the data is organized behind, let's say, under the hood of IMONET physics. So we have a number of datasets. Some are datasets of metadata, so you can access it because it's providing a sort of asset, a list of platforms and resources that you have. And this is organized in a hierarchical level, because of course we are mentioning let's say a concept that is temperature. A temperature is made by platforms that are collecting time series, that are collecting profiles. So we have to somehow reorganize a bit this hierarchy in the same way, in a proper way. And then once you have identified your let's say packages, the packages that you are interested in, then you can really access the data. So usually what you want is access the data, that is that, let's say, data set, but you need to start from this because you need to do your asset mapping. If you play with that data set, you get a list like this. So you have the platform name, the platform code, the last position, the kind of issue that has been collected, all the temporal information. And what we are doing is attaching to this metadata also some information about if this data has been published with a GUI, so we have a link, and also if this dataset is coming, or this platform is coming back to back with a best practice. So if we know that there is a best practice applicable to that specific dataset, we try to map it. And as you can already see, we have some empty spaces over there. So we did this exercise in order to see which is the level. More thought about that. So when you access this data set, you get, of course, the full picture of the information, because beside looking at the position and the value, then you can have the full, let's say, complementary information and history of that specific platform. So this is an example of an Argo float that has been deployed by the scripts. And so you see that you have all the information. And why it is important to have this kind of information? Because then you can really close the loop. So you get your access, so you list your platform, you have a link to see the data, this is one. You have a link to see the DOI of the data, so you're sure about versioning and etc. And then you also may access to the methodology that has been the best practice that has been applied to that one. So Argo is an easy one because they are very well organized. The other platforms, we have degrees of improvement, I would say. So which is the status? So having this in mind, we did this exercise in order to see which is the status of the information that we have in Eminent. So I played with only one of the dataset that is listing the platforms. In this case, we are not considering the CTD, so it's only platforms. So out of the about 95,000 platforms that are considering this dataset, about 50,000 have a link of the best practice. But which, let's say, best practice and how many best practice has been applied? So we have a reasonable number of platforms that are are providing this kind of information, but the number of best practice that are officially mentioned in this are the number is very little. So we only have 6 best practice mentioned over the 95,000 platforms. And these platforms are mainly applied to this kind of platform type. So we have some platforms related to the ADCP, Argo, of course, HF Radar, Glider, and so on. And these are the ones that you may find, because these are the links, the links that I listed there are pointing to those best practices. That somehow makes sense because are exactly the ones that are listed in the platform. So to say, we have large degree of improvement, and so we need to keep working on this. And this is also a recommendation that we have to push towards the integrators and the providers, because again, as we were discussing about uncertainty, also best practices are related to that, and so we need to attach this kind of metadata back to the data. So we need to go back to the provider in order to have this kind of information.
Which says it needs cooperation of the community.
Yes.
And just time for one question, a quick one. Yes.
I saw that one of the links were to a Horizon 2020 project, Atlantis. Is that a sustainable place to store best practices, or would you need an exercise to kind of grab those before?
We need the exercise to elevate this. So this is something that we need to tackle. Absolutely. Yeah.
That's why the Ocean Best Practice System was created. There were projects that the very, very good practices were created. They were put on their website, and 3 years later, the website disappeared. And we took the mission of collecting from the projects all of the practices that are used, and then we have a sustainable repository for the long term. Yeah.
And by the way, that one are very important because some of those practices are also applied to ocean science data. So it's important to elevate them into.
Yeah, the whole FIXO3 got lost. Exactly. Yeah. FIXO3 was a remarkable series of methods and best practices. Okay, we need to move on.
Thank you.
Okay, we'd like to now turn to the question of selecting methods. I guarantee you we're going to run out of time. So some of this will go quickly and we can always redo it at another meeting. And let's turn then to the question of the selection. And this is the classic problem. And I love this cartoon because it really expresses a degree of frustration in the community. The particular Ocean Best Practice System has more than 2,000 records. And the question comes to us, how do we know which one to use? What do we do when we're looking for something specific? And the search mechanisms work, and there are various options for the search mechanism. define practices that you can sort according to subject or EOV, maturity and endorsement, which I'll talk about briefly, date, etc. And we have other options. We can go forward. And I'd like to now turn to Beatrice, and let's talk about some of the really exciting new things that are occurring.
Thank you, Jay. Good morning. Yeah. So with Jay and his team, we're currently working on something new, which is like having a single access to a federated network of practices. And FedNet is the front end of OPFN, which is the Ocean Practice Federated Network. And with that, we have this graph that shows us how it works. And basically, we have the user interface, which I'll show you in a second, and from which we get the access to content. Right now, we are retrieving metadata from two different repositories, the OBPS and the FAO repository, and from which we get the metadata harvester. And all of these metadata get into the database of OPFN, from which we get the content discovery. On the right-hand side, you have the operational system for OPFN. There is a nice milestone, the milestone 17, that came up 2 weeks ago. So I strongly suggest you to have a look at that to have more insights on this topic. So FedNet, this is the portal that we are developing. From here, you have different filters that you can select. You have age right now, and on the bottom right, you have the number of practices that are now available on FedNet. You can, of course, select the two sources that we currently have, which are FAO and OBPS. And if you select one source, you have, of course, in this case, for FAO, we have the number of practices regarding the source. For FAO, we have now approximately 34,000 potential practices that are progressively being updated on this portal. And here you have the list of the cards that you have selecting your filters. If you click on the information point on the card, you will be directed on the specific information of that practice, with the authors, for example, a brief explanation with a summary and the metadata attached to this practice. As you can see, most of them, they lack of information about the metadata. So this is something that we need to work on. You can also select the maturity level. And when we did this exercise, we came across some discrepancies because we need, as Jay said before, we need to define certain vocabularies. Because, for example, when you create a filter as is from the metadata that we have, sometimes you can get like multiple for the same, like pilot and demonstrated, or pilot or demonstrated, but we don't know if it's the same concept or if a different one. So we need to define some vocabulary for that. Also, this is for the OBPS. We retrieved 204 sensors. And also for this, we have multiple sensors, maybe with the same name, but even here we need to define some vocabulary to have better filtering in this portal. Another analysis that we have done is on the number of keywords, both for OBPS and FAO. And as you can see, there are quite a huge number of keywords. And we think that those are too much for a scrollable search. And so our suggestion would be, like, for example, to extract the top 15 keywords for this one. And it's the same we did for FAO. Even here we have a larger number of keywords. This is my last slide, yes. And yeah, we are currently working with Jay and his team. Of course, we are on the way of also adding other repositories, for example, ISIS, that we will do in a few months. So this is the start of our work, and we go on for a few. Thank you.
Thank you very much. I think this is very exciting. I would like to just leave us then with one last thing. There's more in the presentation, but let's stay focused. And that is the evolution of best practices in terms of being able to search for mature practices or endorsed practices or practices that have been identified for having a better value or better use. And in the maturity curve, which or model, which we published July or August last year, and have done significant number of interviews with, we have the three top levels, 3, 4, and 5, which are defined and documented, broadly adopted, and then finally I call it sustainable rather than mature, because sustainability of practices, as Stefan said, is very, very important. And so we have the different attributes. In the level 4 now, it's used by multiple institutions. It can have some means to verify whether it's been implemented properly and enable replication, and particularly guidelines for evolution. Many times practices, particularly those published in the literature, don't tend to think about evolution. I did my paper, boy, I'm glad I got it done. But when you're talking about a practice that needs to be sustained, you can't do it on that basis. So I want to come to the final one. This is where, like standards, you have it endorsed by an expert panel. It's adopted regionally. There are specific protocols, user feedback, surveys, whatever you have it for improvement. And now we're coming to the really key, which is the process to assess quality. I want to say specifically uncertainty and quality more generally. So following up on what Johannes was talking about, this is the essence of a sustained and mature practice. And then finally, I just want to show you some of the work that we're doing. We've gone out and interviewed the key authors, usually the lead author, of various practices that have been identified. I give Abid credit for the identification process. And we're up to about, we are up to 64 out of about 150. So we've gone through half the cycle. And these are personal interviews. They last an hour or more in many cases. And we go through the attributes, and you can see the variety of topics. For example, genetic data analysis shown does the hydrographic materials. There's quality control in Australia for HF radar, multi-beam, et cetera, et cetera. Just leave you with some thoughts. I know we need to finish up now. And two things, probably most important. Best practices are living documents. We do expect them to improve. We do expect them to change, not only due to technology, but the learning experience and some of the innovation of young people coming in and trying the things and finding new and better ways to do it. We have to address different infrastructure capabilities. We've had real challenges in Africa and South America where they don't have some of the metrology capabilities. They don't have the infrastructure to do the measurements. And then finally, OBPS is the center point for putting in your methods, your practices, and increasing the visibility of your work. And with that, thank you very much.
Maybe just one final question. No. Yeah, but
yeah, I can speak. Oh,
Okay, well, here.
Thank you so much. Thank you, Jay, and everyone for the really very useful presentations and clear presentations. So one of the main differences, actually, Jay, between standards and best practices, because there are many best practices that are merely standards, right? But one of the main things is that best practices are for free. And that's why many, researchers are interested to keep them as best practices, because they will be endorsed by ISO or CTM, they will be payable. and they will not be accessible by the community the way they are now as best practices. So how do you think, I mean, we can get rid of that? So even standards, I mean, could be for free, accessible, and in that way we will be shifting from the community of best practices to standards, and somehow, I mean, moving forward, right?
Yeah, I think it's a very good question, Abid. Thank you for that. There are two answers. The standard should be those things that will be stable over time and maybe don't have so much impact from rapid technology changes. And I have been talking to the standards organizations, SAN, IEEE, and OGC, and asking how we can break down the paywall. And there's some interesting discussions going on. So in the future, I'm hoping that there will be a set of practices that can be outside the paywall, a set of standards that can be outside the paywall. We're working on that.
Good, thank you.